So probably the most famous example of Simpson's paradox comes from the 1970s University of California, Berkeley gender bias case. So UC Berkeley was accused, I believe, of gender bias in its admissions practice. And if you look at the total for male and female, you might conclude that as well, or conclude that as a possibility, at least. Tell me what percent of men were accepted? 47.2. And how about for the women? 30.8. So as you can see, the acceptance rate for women is lower than that of men. However, when you look at the numbers that make up those totals, a different picture appears. So these are different programs within the university that you can apply to, and this means how many were accepted out of how many applied. So please tell me the percent for males in program 1. 61.9. And how about for females in program 1? 82.4. Males in program 2, please. 62.9. And females in program 2? 68.0. Okay. Males program 3? 33.7. And females in program 3? 35.2. Males in program 4? 5.9. And females in program 4? 7.4? 0. Interesting, right? So overall, females are being accepted at a lower rate than males, 31 versus 42%. But when you look at each program, in all 4 cases, females have a higher acceptance rate than males. So if there's gender bias going on here, it's the opposite of what one might think based on the totals. One might say that they are favoring women over men. Higher, 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 higher. This is an example of Simpson's paradox, which is named after the statistician who discovered it, although he probably wasn't the first to discover it. It's just that his name got attached to the concept. My question for you is, or my challenge for you is why is this happening? These are all truths. There's no lying going on here. But why are we getting a different picture painted when we look at the total acceptance rates versus the constituent acceptance rates? Kevin?
For the females, the ones with the higher acceptance rates have lower numbers of females in it, so the higher percentages have less effect.
Okay, so I would modify that statement a little bit. It's not just that the females have lower numbers vis-a-vis males. It's more of a relative frequency. So a lower percentage of females are applying to programs 1 and 2 than programs 3 and 4, and the opposite is happening for males. And then what else, Kevin? Like, how is that changing things?
So since there are more females applying for lower percentages, since the magnitude of the lower percentage is bigger, it has more of an effect to drive the percentage.
Yes, it's driving the percentage down for the females, and for the males it's driving the percentage up. So take a look at where males are tending to apply. They're tending to apply to programs 1 and 2. Look at the acceptance rates for programs 1 and 2. They are the highest. One might argue they're the easiest to get into. So because the males are tending to apply to those programs, their overall rate is going to be boosted. The females, the opposite is happening. They're applying to the programs that are more difficult to get into, especially program 4, which has a very low acceptance rate. 341 females are applying there, and that's dragging their overall rate down. So if you take 341 and divide it by the number of females, 40% of females are applying to the hardest to get into program. So that's going to weight the overall average. Any questions? Okay. So, yes?
You said this was like a real case in BC Berkeley.
Yes.
Like what if that year male student just happened to be smarter than average female? And how are they so sure that that's a bias? If that's just a coincidence?
Well, we can't be so sure. All we have is the data. But the data provides us evidence of possible bias.
Possible.
Yeah,
So that possible led to like an actual case of people blaming BC Berkeley for.
I believe so.
Did they work?
I'm not sure. You can check it out online. Yeah. You can type in UC Berkeley gender bias Simpson's paradox.
I feel like it would be more biased for the university to try to keep it 50-50, even if male or female were smarter than the other.
Biased if they try to keep it equal.
Yeah, because then you'd be like forcing it.
Okay.
No, but I'm just.
Okay.
This is a real case. That was,
Yeah. All right. So Simpson's paradox. That's what's going on here. And in my words, what Simpson's paradox is, this refers to situations in which the overall average or rate or percentage presents a different picture than the constituent let's call them averages or rates. So to relate that to what we just did, if you look at the overall rates, you see that men are being accepted at a higher rate than women. However, when you look at what makes up those ratios and calculate the constituent rates, you find that the opposite is happening. That females are being accepted at higher rates in this case, all 4 programs. So you might ask, when does Simpson's paradox arise? Hopefully some of you can see it now. It arises when you have a discrepancy, usually a big one, between the number of individuals in one group and the number of individuals in another group across a category. It's not, some people in the other classes were just looking at these numbers and saying, oh, it's because so much fewer women applied to Berkeley overall. No, it's not that. It's based on where women are tending to apply. They're tending to apply to the programs that have lower rates overall. Okay? So notice 825 versus 108. But I can't just do that. What I really should do is 825 out of how many males there are, 38%, and 108 divided by how many females there are. So 38% of men are applying to program 1, whereas only 13% of women are. So this happens when there is a discrepancy in subgroup sizes. With respect to that group's total. I'll put that in parentheses. Across categories. It's not a great way of articulating it. It's the best I can do right now. You might find a better way in the book or online. I think it's more easily understood by using an example like this. Again, any questions on Simpson's paradox? Yes?
Is there like a way to normalize it so you can like have equal percentages? Like, you know how it's because there's a discrepancy between numbers, would you have to like balance out the numbers to see like true values? Like in comparison to one another?
I'm not sure if there are true values. If we made this equivalent to 825, thank you, David. So, if we multiply this numerator by 7.63 to normalize it, we're going to get an equivalent rate. So it would be 108 times 7.64, 679.8 divided by 825.12. You're welcome. You get the same value, so I'm not sure if there's value in doing that. Yeah, I'm not sure if that path is going to lead you anywhere worthwhile. Okay? But it's, you know, good to consider it.
You just have to recognize that there's a discrepancy, like you can't do anything about it.
What I would do is I would do what I asked you to do, which is find the relative frequencies or the rates, and then compare those. And at the same time, notice where these subgroups, like men, are tending towards, like I was doing before. Okay?
Yeah.
Other questions on Simpson's paradox?